All right, let's dive in. Today, we're going to pull back the curtain on the real magic behind artificial intelligence. And you know, it's not just about clever algorithms. It's about the incredible hardware that makes it all possible. The story of how it all works together is, believe me, even more fascinating than you might think.
I mean, think about it for a second. You ask some super complex question, and bam, in seconds, you get this coherent, detailed answer back. How on earth does that happen so fast? It seriously feels like magic, but the reality is way, way cooler. The secret, it turns out, is this deep, symbiotic relationship. It's a partnership between the physical hardware doing all the heavy lifting and the smart software that tells it exactly what to do. And this partnership, it's the engine behind the entire AI revolution.
So, in this explainer, here's our game plan. We'll start with the engine itself. Then, we'll uncover a kind of free lunch performance trick. After that, we'll see how software acts as this brilliant smart layer. We'll even get a peek at the next frontier for GPUs. And finally, we'll tie it all together with something called the Great Feedback Loop that drives all of this incredible progress.
Okay, so let's meet our hero, the Graphics Processing Unit, or GPU. You know, these things were originally designed for video games, to make dragons and explosions look awesome. But it turns out they were absolutely perfect for the massive parallel calculations that AI needs. They are the true workhorses, just crunching billions of computations every single second. Now, to understand the next big leap, we've got to grasp a core concept: bit precision. The easiest way to think about it is like image resolution. Using more bits gives you a super precise number, which is great, but it's slow, and it eats up a ton of memory. Using fewer bits is way faster and leaner. So the big question has always been, can we use fewer bits without totally wrecking the accuracy? And that brings us to what honestly feels like a free lunch. The industry has figured out how to dramatically lower bit precision for AI tasks, and in doing so, get these huge performance gains without a noticeable drop in quality. It's an absolute game changer. So here's that trade-off in action. The old standard 16-bit floating point, or FP16, yeah, it was accurate, but it was slow and a real memory hog. The new trick, using formats like 4-bit floating point, or FP4, is just dramatically faster and lighter. And the craziest part? It still maintains surprisingly high accuracy for these massive AI models. And we're not talking about a small bump in performance here. According to early reports on new GPU architectures, just moving from 8-bit to 4-bit precision can nearly double the speed of AI inference. That means faster answers from your chatbot, all thanks to this one really clever trick. And this isn't just some theoretical idea floating around. No way. The biggest players are all in. NVIDIA is making FP4 a core feature, a first-class citizen of its next-gen Blackwell GPUs. Microsoft has already shown you can run a massive model on a single GPU using this technique. And of course, AMD is right there with them. The whole industry is betting big on this.
But, having this amazing hardware is only half the story. I mean, how does a developer actually use it? That's where the smart layer of software comes in, and it acts as this absolutely crucial bridge.
This whole process is called abstraction, and it is just incredibly powerful. It starts when a company like NVIDIA builds a new hardware feature. Then a software framework, say Hugging Face, they integrate it into a simple library. A developer can then add just one single line of code to tap into all that new power. It's beautiful.
And that one line of code, it might look something just like this. Instead of model.half for 16-bit, a developer might just type model.quantize for. That's it. That is literally all it takes to unlock that 2x speedup we were just talking about. It's honestly incredible.
This all works so seamlessly because of this rich ecosystem of tools that's been built up. You've got libraries from Hugging Face that automatically optimize models, NVIDIA's own engine cleverly picks the best precision for each part of an AI model, and then tools like Bits and Bytes let you train these huge models on less hardware. It's a team effort.
So, what's next? If GPUs are already this good, where do they possibly go from here? Well, the answer seems to be specialization. They're becoming even more tailored for the very specific demands of AI.
We're already seeing hints of what's coming down the pike: dedicated attention processing units built just to accelerate models like ChatGPT. The new Blackwell architecture mentions specific tweaks just for these models. And the really grand vision? It leads to what they're calling AI factories, just massive GPU clusters processing data nonstop. So this brings us to what might be the most important takeaway of all. It's not just about the hardware, and it's not just about the software. It's about the powerful, self-reinforcing cycle they create when they work together.
And here is that loop in action. It's so simple, but so powerful. Faster GPUs allow researchers to build bigger, more powerful AI models, right? Then those amazing new models create this huge demand for even more computing power. This pushes the hardware makers to design even faster, more specialized GPUs, and the cycle just begins again, accelerating with every single turn.
As the source material puts it so perfectly, it's a thrilling feedback loop. This synergy, this partnership, is what has taken us from those early AI experiments to the generative AI we see absolutely everywhere today, and it's what's going to propel us into the future.
So why does all this matter to you? Well, if you're interested in AI, understanding how to tap into this hardware and software ecosystem is basically a superpower. It's the difference between walking and driving. It lets you take your own ideas and projects so much further and so much faster.
This incredible partnership between silicon and code has built the entire world of AI that we live in today. So the only real question left is, as this loop continues to spin faster and faster, what amazing, unpredictable, and powerful things is it going to build for our future?